Hello everyone, my name is Nurul Binti Ibrahim and my metric number is J20A0597 and I'm from program SH. Today I will demonstrating about force and motion simulation. The experiment that we are about to do is to determine the difference between friction force and applied force value. So what is friction force? Friction force is opposing the motion of the block is equal to applied force but acting in the opposite direction. When the applied force is greater than the maximum static frictional force, the object moves but still experience friction. This is what we call kinetic force. So as you can see here, we had the simulations of kinetic friction on an inclined plane. So we have initial velocity, gravity, mass, convective static friction, convective kinetic friction, and also an angle that we can adjust for this simulation. Right now, we have a block and an inclined plane. So today we want to see what will make the block start moving. It will depend in two criteria, and it is the inclined plane angle and the convective static friction. So let's start our experiment by using a 30-degree angle and one convective static friction. So let's see, the block still doesn't move, so how about we use a 0.2. Okay, as you can see here, the block finally start moving. So I conclude that maybe convective static friction has to be lower so that the block will start moving from its static position. So let's do for an angle next. So next is 0.42 for the convective static friction and a lower angle like 70 degree. So as you can see here, it doesn't move. So how about we do it a little bit higher, like 28 degree. So I see here that the larger the angle, the block will finally start moving than the lower angle. So the block are not to accelerate down inclined plane because of the unbalanced force. To conclude here, the lower the number of the convective static friction, the block will finally start moving, and also the angle are large. When the angle are larger, the block will also start moving. So that is from me today. Thank you. Have a great day.